In applied mathematics, in the first unit, the second concept, what we are going to learn is allegation and mixture. Allegation means mixing two or more ingredient in some ratio. Problems based on allegation and mixture are asked in various competitive examination. The formula of allegation and enables us to find the ratio in which two or more ingredients at the given prices must be mixed to produce a mixture at desired price. For example, if you have two ingredients of different prices, the prices per unit of cheaper ingredient is denoted by C, and the price per unit of dearer, that is little bit costlier, is denoted by D, and we are going to mix these two product. Okay, the cheaper product with the price C and a dearer product which is at a price D is going to be mixed to get a mixture whose desired price is M. So in which ratio we have to mix both the ingredients? So this is the formula we are going to use it. Quantity of cheaper ingredient divided by quantity of dearer ingredient. So cheaper is in the numerator and dearer is in the denominator. So C by D is equal to cost price of dearer minus mean price of the mixture divided by mean price minus cost price of cheaper. So dearer is going to be in the numerator and cheaper is going to be in the denominator, and this is the formula we are going to use. D minus M by M minus C. So the ratio in which the two ingredients, the cheaper one and the dearer one, to be mixed to get the required mixture of the required cost. It is going to be quantity of cheaper ingredient divided by quantity of dearer ingredient is given to be D minus M by M minus C. How many kg of sugar costing rupees 45 must be mixed with 30 kg of sugar costing rupees 35 per kg, so that there may be a gain of 12% by selling the mixture at 47.04, 47 rupees 4 paise per kg. So it is going to be a gain. It is going to be a gain. So first of all, we must find what is the cost price of that mixture. The selling price is going to be of the mixture is rupees 47.04, that is 47 rupees 4 paise. So selling price is X plus 12 by 100 into X. We have the formula, selling price is nothing but cost price plus profit. So we take LCM. Selling price is already given to us 47.04. When we take LCM, it is 100x plus 12x divided by 100. That is equal to 112x by 100. So from here we are going to get the value for x. So this implies x is equal to 47.04 into 100 divided by 112. 47.04 into 100, it is 4704 divided by 112. So we divide 470 by 112. So the answer is going to be 42. So we have cost price of the mixture is rupees 42. Okay, we are going to find the ratio in which it is mixed now. So one type of sugar is going to be rupees 45 per kg. The other one is going to be 35. So cheaper one we write first. C is equal to 35 and a little bit costlier is going to be 45 and the mixture price is going to be 42 and here we calculate D minus M. D minus M is equal to 45 minus 42, that is equal to 3, and M minus C is going to be 42 minus 35. So ratio of the mixture, quantity of rupees 35 per kg sugar divided by quantity of rupees 45 per kg sugar is going to be D minus M divided by M minus C. That is nothing but 42 minus 35 is going to be 7 actually. Okay. So it is going to be 3 by 7. Now they are given 30 kg sugar. Rupees 35 rupees per kg sugar. We have 30 kg and we are supposed to calculate what is the quantity of rupees 45 per kg we have, and we take it as X, and using the ratio (30 kg divided by X is equal to 3 by 7, which implies 3x is equal to 210. So x is equal to 210 divided by 3, that is equal to 70 kg. So we must have kg of rupees 45 per kg sugar should be mixed with rupees 35 per kg sugar 30 kg. In this problem, a vessel contains a mixture of two liquids X and Y in the ratio 3:5. In that mixture, 8 liters of mixture are drawn off from the vessel. In this problem, a vessel contains a mixture of two liquids X and Y in the ratio 3:5. 8 liters of the mixture are drawn off from the vessel and 8 liters of the liquid X is filled in the vessel. If the ratio of the liquids X and Y after that mixture of 8 liters of liquid X, it becomes 7:10. How many liters of the liquid X and Y were contained by the vessel initially? This is the question. So you must understand the question first. We are having liquid X, liquid Y, and they are mixed in the ratio 3:5. Okay. In this mixture, we are going to remove 8 liters and instead we are going to add 8 liters of liquid X. So we are adding more amount of X. After that, the ratio of the mixture turns out to be 7:10. So how many liters of the liquids X and Y are present in the beginning? This is what the question is. Initially, we are having quantity of liquid X. We take it as 3x because it is in the ratio 3:5. Quantity of liquid Y is taken as 5x. Now we are going to remove 8 liters of the mixture. After removing this 8 liters from this mixture, which is going to contain the liquid X and Y in the ratio 3:5. Quantity of liquid X will be 3x is the initial value and we are going to remove 3 by x of. Now we are removing 8 liters of the mixture because it is going to be 8 liters of mixture. Because we are removing 8 liters of the mixture is going to contain X and Y in the ratio 3:5. So after removing 8 liters of the mixture, quantity of liquid X will be equal to 3x minus 3. Because out of 8 liters, 3 liters will be your liquid X and 5 liters will be your liquid Y. And the quantity of liquid Y will be equal to 5x minus 5. Next we are going to add we are going to add 8 liters of liquid X. After adding 8 liters of liquid X, the new combination will be quantity of liquid X in the new mixture will be, already it is 3x minus 3. Now we are going to add 8 liters. So it will be equal to 3x plus 5. Quantity of liquid Y. There won't be any change for liquid Y. It will remain 5x minus 5. Now the ratio of the new mixture they have given to us. Ratio of new mixture is 7:10. This means 3x plus 5 divided by 5x minus 5 equal to 7 by 10. This is the ratio. We cross multiply now. When you cross multiply, what's the answer you are going to get? 10 into 3x, 30x, 10 into 5, 50 is equal to 5x into 7, 35x minus 5 into 7, minus 35. We bring like term to one side, so we get 30x minus 35x is equal to minus 35 minus 50. So when you simplify this expression, we get minus 5x is equal to minus 85. When you solve this, the answer is going to be x is equal to 85 divided by 5. It's nothing but 17. Now initial value of quantity of liquid X is going to be 3x, which is equal to 3 into 17, which is nothing but 51 liters. Liquid Y, 5x. So 5 into 17, which is nothing but 85 liters. So this is the answer for this question. Similar to this, we are going to have another problem. Hello students, today we are going to see another problem. Two vessels P and Q contain milk and water in the ratio 5:3 and 13:3 respectively. In what ratio mixtures from the two vessels should be mixed to get a new mixture containing milk and water in the ratio 3:1. So we are having two vessels already, P and Q. In P, milk is to water ratio is 5:3. In Q, milk is to water is 13:3. So in vessel P, quantity of milk present is 5/8 part. In Q, quantity of milk present is 13/16 part. How we got this 8 and 16? The ratio is 5:3. So the total ratio value will be 5 plus 3, that is equal to 8. And here 13:3. So here we are having 13 plus 3, that is equal to 16. That's why here it is 8, here it is 16. Now we are going to mix these two milk from P and Q in a certain ratio. Okay. So that the new mixture will have the milk and water in the ratio 3:1. So the new mixture is going to have the ratio milk is to water 3:1. So here quantity of milk present is 3 divided by 4 part. So here we have the values of the quantity of the milk present in vessel P, vessel Q and the mixture. Mixture is going to be 3/4. And we can see that the denominators are going to be three different values: 8, 16 and 4. So we convert all the thing in terms of, we convert this one to common denominator. So quantity of milk in vessel P will be equal to, for 8, 16 and 4 the LCM will be 16. So we have to convert 5 into 2 divided by 8 into 2, that is equal to 10/16. And quantity of milk in vessel Q will be equal to, it is going to have the denominator 16, so we need not multiply with anything, so 13/16. And the quantity of milk in mixture, we combined both the milk present in vessel P and vessel Q. It is given to be 3/4. So we convert, we multiply with 4 with in both numerator and denominator. So we get the answer is 12/16. Now we are supposed to find the ratio in which the milk in the vessel P and milk in the vessel Q are mixed together. So for that we are writing the values. 12/16 is the mixture value M, and the cheaper one is going to be 10 part out of 16, and little bit costlier, dearer one will be equal to, D will be 13/16. That's why we are converting all the fractions to have a common denominator. Then only we can compare the numerator to check which is cheaper and which is costlier. Now I am going to calculate D minus M. D minus M is 13/16 minus 12/16. minus 12/16, which is equal to 1/16. Next thing is M minus C. M minus C is, M value is 12/16 minus C value is 10/16. We subtract. So 12 minus 10, because the denominator is the same, we can subtract the numerator. 2/16. So now we are going to find the ratio. Quantity of milk from vessel P divided by quantity from vessel Q will be 1/16 divided by 2/16. 16 cancel. So the answer is 1/2. So the ratio from vessel P and vessel Q is 1:2. So this is the answer. Let's say another problem. Two vessels A and B contain milk and water in the ratio 3:2 and 7:3. And same type of problem only this is. So here we are having two vessels again. Vessel A and vessel B. And same thing, milk and water. It is in the ratio 3:2. Here it is milk and water. It is in the ratio 7:13. And we are going to concentrate only on the milk part. Okay. So the total ratio here is going to be 3 plus 2 is equal to 5. Here 7 plus 13 is equal to 20. And we combine, we take some amount from vessel A and some quantity from vessel B and mix together. Okay. In the ratio 2:3. So they are mixing. The ratio is given to us. Hello students. Here we are having a problem. Two vessels A and B containing milk and water in the ratio 3:2 and 7:13 respectively. And they are mixed in the ratio 2:3. We are taking 2 parts from vessel A and 3 parts from vessel B, and they are mixed together. Here we are supposed to find the ratio of milk and water in the final mixture. We are supposed to find the ratio in which the milk and water are present in the final mixture. In previous problem we studied we found out the ratio in which the milk from vessel A and vessel B are mixed. But in this problem, they have given the ratio in which the mixture from vessel A and vessel B is mixed. The ratio is given to us. Okay, and we are supposed to find the ratio in which the milk and water are present. And we start the problem. Vessel A, milk and water. It is given to be 3:2. Is it clear? And vessel B, milk is to water is 7:13. And here it is 3 plus 2. The total ratio will be 5. Here 7 plus 13, that is equal to 20. And in the mixture, we don't know what is going to be the ratio in which that milk and water is going to be present. Okay. Now, quantity of milk in vessel A will be equal to 3/5 part. Quantity of milk in vessel B will be 7/20 part. and we take the LCM for 5 and 20. Okay. So for 5 and 20, the LCM will be 20. And we assume that the ratio of the mixture will be x by 20. Now of these two values, we have to convert this one to common denominator. So quantity of milk in vessel A will be equal to 3 by 5. We make it to common denominator, so we multiply by 4 in numerator and denominator. So this is 12 by 20. And quantity of milk in vessel B, it is given to be 7 by 20. It is going to have the same denominator. And the mixture is going to have, we don't know the value, we are going to find the value. We assume it to be x by 20. So we have the situation. Mixture is going to have x by 20. Of the two values, 12 by 20 and 7 by 20, which one is cheaper? C is going to be 7 by 20 and dearer will be equal to 12 by 20. Now we are going to calculate D minus M. D minus M will be 12 by 20 minus x by 20. So it is 12 minus x divided by 20. Okay. And the next one is M minus C. M minus C will be x by 20 minus 7 by 20. So it is x minus 7 divided by 20. Now quantity of mixture from vessel A divided by quantity of mixture from vessel B is given by the formula D minus M divided by M minus C. That is nothing but 12 minus x by 20 divided by x minus 7 divided by 20. This 20 we can cancel it off. And the ratio is given to us already. It is given 2 by 3, 2 is to 3. So 2 by 3 is equal to 12 minus x divided by x minus 1. We cross multiply. When we cross multiply, you get 2 into x minus 7 is equal to 3 into 12 minus x. So 2x minus 14 is equal to 36 minus 3x, which implies 2x plus 3x is equal to 36 plus 14. So 5x is equal to 50, which implies x is equal to 50 by 5, that is 10 liters. 10, x is equal to 10. So milk is to water is going to be 10:10. That is nothing but 1:1. So this is the answer. So this is the ratio in which the milk and water present in the final mixture. We are going to see another problem. A milkman has 2 cans. In the first can, it is going to contain 75% of milk and the rest water. In the second can, it is going to be 50% of milk and the rest is going to be water. How much mixture should we mix from each can so as to get 20 liters of the mixture such that the ratio of milk and water is 5:3? Again, ratio of milk and water is given. How much mixture should we mix from each can? So how much we have to take from the can 1 and how much we have to take from can 2 so that the mixture will have, the resulting mixture will have the milk and water in the ratio 5:3. So we take can 1. It is going to have milk 75%. That is 75 by 100. So water will be remaining portion, correct? So water will be 100 minus 75%. And it is going to be 25%. That is 25 by 100. So milk is to water ratio, if you take, it will be 75 by 100 is to 25 by 100. Sorry, 70, yeah. So when you simplify this ratio, the ratio will turn out to be 3:1. And in can 2, milk is going to be 50%. Then how much the water will be? How much percent water will be present in that? It is 100 minus 50%. That is nothing but 50%. So milk is to water, if you take, it is going to be 50 by 100 is to 50 by 100. That is nothing but 1:1. And the mixture, we are going to combine. We are going to take some amount of mixture from can A and some amount of mixture from can B, and we are going to mix, and the resulting is going to have the milk and water in the ratio 5:3. So we start. Quantity of milk in can 1 will be equal to the total ratio here, it will be 4. So we get 3/4 part. Same way, quantity of milk in can 2 it is going to be 1/2 part. Quantity of milk in the mixture, it is nothing but, this is going to be 8, so 5/8 part, and it is going to be different denominators, 4, 2 and 8. We try to convert it to common denominator. So LCM for 4, 2, 8, LCM will be 8. So we convert all the fractions to the common denominator 8. So we multiply here with 2. So 3/4 into 2/2. So it is 6/8. Here we multiply 1/2 with 4. that is nothing but 4 by 8, and this is going to be the same thing, no change, 5 by 8. So out of 8 part, 4 is going to be milk, 4 is going to be water. So this is going to be cheaper one. So C is equal to 4 by 8. And dearer, little bit costlier, will be going to be 6 by 8. And mixture is going to be 5 by 8. And here we are going to calculate D minus M. D minus M is equal to 6 by 8 minus 5 by 8, that is equal to 1 by 8. M minus C. Five by 8 minus 4 by 8, that is also equal to 1 by 8. So amount or quantity taken from can 1 divided by amount or quantity taken from can 2 is equal to 1 by 8 by 1 by 8. That is nothing but 1 by 1. So if it is going to be 20 liters, if it is going to be 20 liters, the ratio is going to be 1:1. Okay. So 10 liters from can 1 and 10 liters from so the ratio of the mixture from can 1 and can 2 are going to be 1:1. So can 1 is to can 2 is equal to 1:1. So the total ratio will be 1 plus 1, that is equal to 2. Now we are going to find how much we have to take from can 1 and how much we have to take from can 2. So amount of mixture taken from can 1 is equal to 1 by 2 into 20, that is nothing but 10 liters. So amount of mixture taken from can 2, again 1 by 2 into 20, 10 liters. So to get the resulting mixture in the ratio 5:3, we are supposed to take 10 liters of mixture from can 1 and 10 liters of mixture from can 2. Hello students, in this problem we are going to find the ratio in which a person should mix two sugar solution. One is 30%, the other one is 50% concentration respectively, so as to get a solution of concentration 45%. Okay. We are having the first sugar solution 1. Here it is going to have concentration 30%. %30 is nothing but 30 divided by 100. that is nothing but 3 by 10. So out of 10 part, you will be having only 3 part as the sugar concentration. In sugar solution 2, concentration is going to be 50%. That is nothing but 50 by 100 percentage it is. So it is 50 by 100. So this is nothing but 1 by 2, but we try to retain the same denominator so that the calculation becomes convenient for us. And the resulting mixture concentration is 45%, which is simplified as 45 by 100. And when you simplify this expression, this turns out to be 9 by 20. So here we are having two denominators, one is 10, the other one is 20. So we try to find the LCM. LCM of 10 and 20, which is naturally going to be 20. So concentration of 30% sugar will be equal to 3 by 10 multiplied with the 2 by 2, it will be 6 by 20. Concentration of 50% sugar, it will be 5 by 10, again we multiplied with the 2 and divide by 2, it is 10 by 20, and the mixture will be 9 by 20. So this is 6 part out of 20 and this is 10 part out of 20. So C is going to be 6 by 20 and D is going to be 10 by 20 and mean is going to be 9 by 20. Now we calculate D minus M. D minus M is 10 by 20 minus 9 by 20, which is nothing but 1 by 20. M minus C will be 9 by 20 minus 6 by 20. So common denominator will be 20. 9 minus 6 will be 3. So quantity of 30% concentration sugar we are finding the ratio of the quantity to be taken from 30% and 50% is equal to 1 by 20 divided by 3 by 20. So 20 cancelled, it is nothing but 1 by 3. So the ratio we must take 30% concentration sugar is to 50% concentration sugar is 1:3. This is the final answer. So this is the ratio in which we have to mix the two concentration to get the required 40% concentration. Next question. A shopkeeper has 1 quintal of wheat, part of which she sells at 18% gain and the rest at 28% gain. In total, she gains 24 percentage. Find the quantity of wheat sold at 18 percentage and 28 percentage. Okay. Here both are going to be profit. So we take all the values with the plus sign. So the first one is sum part. So here in this problem we take straight away C is equal to 18 percentage, that is 18 percentage profit, that is 18 by 100, because this is a smaller value. And the next one is D, higher profit, 28 percentage, that is nothing but 28 by 100. And the mixture combining together, the total profit is going to be 24 percentage. So that is nothing but 24 by 100. So we write C is 18 by 100, D is 24 by 100, M is going to be actually D is 28 by 100, M is going to be 24 by 100. So C is written this side, left side, D is written right side. So we calculate D minus M. D minus M is 28 by 100 minus 24 by 100. That is nothing but 4 by 100. M minus we calculate. M minus C is 24 by 100 minus 18 by 100. So common denominator 100. 24 minus 18 is 6. So we are going to find the ratio in which the quantity of wheat sold at 18% gain and quantity of wheat sold at 28% gain. So quantity of wheat sold with 18% gain divided by quantity of wheat sold with profit 24%. It's nothing but D minus M divided by M minus C, that is 4 by 100 by 6 by 100. So 100 cancel. So this is 4 by 6. That is nothing but 2 by 3. So we are supposed to find the quantity of wheat sold at 18%. So here 2 by 3. So 2 is to 3. We find the total ratio. It is 2 plus 3, that is equal to 5. Out of 5, 2 part will be 18% wheat. Out of 5, 3 part will be 28% gain. So quantity of wheat sold with 18% gain is equal to 2 by 5 into 1 quintal. 1 quintal is equal to 100 kg. So we multiply with 100. So cancels. 20, 2 into 20 will be 40 kg. So 40 kg of wheat should be sold at 18% gain, and quantity of wheat sold at 24% gain will be 3 by 5 into 100, that is equal to 60 kg. In this problem, 900 gram of sugar solution. Okay, here sugar solution is going to contain 40% of sugar in it, and to that we are going to add sugar. Okay, it is not a sugar solution, it is a sugar, so that the mixture turns out to be 55%. Is it clear? So it is a sugar solution. In that sugar solution, quantity of sugar present will be 40 divided by 100 part. That is nothing but, we leave it as such, 40 by 100, or we have to keep the denominator as 20, that we will see in the future stages. And the next one is sugar we are going to add. It is going to be full of sugar, so the quantity of sugar present will be 100%. So it is 100 divided by 100. In the mixture, we are going to have a mixture, correct? In that mixture, it is going to have 55% of sugar. So quantity of sugar present will be 55 by 100 part. And we maintain that the percentage as such, so that the denominators are same. So which makes us to simplify the problem further. We need not take LCM and we need not convert the fraction to given denominator. So we try to write. So 100 by 40 is going to be your C. C is going to be 40 by 100. And D is going to be 100 by 100. And mixture is going to be M. It is going to be 55 by 100. Now we calculate D minus M. It is 100 by 100 minus 55 by 100, which is nothing but 45 by 100. M minus C. (55 by 100) minus 40 by 100, which is equal to 15 by 100. So we got the value for D minus M and M minus C. Now we are going to find the ratio. Okay, how much it is to be added. So quantity of sugar solution divided by quantity of sugar, it is equal to D minus M by M minus C. D minus M is 45 by 100. Divided by 15 by 100. We cancel this 100, and already the quantity of sugar solution it is given to us, it is 900, and the quantity of sugar alone we don't know, it is taken as X, and it is equal to 45 by 15. So we simplify this one, this is going to be 3, which implies 3x is equal to 900. So x is equal to 900 by 3, which is nothing but 300. grams. This is the answer. Similar to this, we are having another problem. In what ratio the water must be added to milk costing rupees 60 per liter, so that the resulting mixture would be worth of rupees 50 per liter. So cost of milk is rupees 60. Cost of water, it is not given, so we take it as 0, and we mix these two in a certain mixture, so that the cost of mixture is going to be rupees 50. Now what is C, what is D, and what is M? Lower cost will be taken as C, higher cost will be taken as D, and the mean value, mixture value, will be taken as M. So C is 0, D is going to be 60, M is going to be 50. So we calculate what is D minus MS. D minus MS, 60 minus 50, that is equal to 10. M minus C, 50 minus 10, that is equal to 50. Sorry. It is 50 minus 0, that is nothing but 50. So we are going to find the ratio in which the water and milk are going to be mixed. See, quantity of water and quantity of milk is equal to D minus M divided by M minus C, that is equal to 10 divided by 50. So the ratio of water and milk is 1:5. This is the answer. In this question, a container contains 40 liters of milk. From this container, 4 liters of milk was taken out and replaced by water. So quantity of milk present is 40 liters, and we are going to remove 4 liters of milk every time, and it is replaced by water. In this process was repeated 2 more times. How much milk is now left in the container? This is the question. So how to answer this question? So amount of water present in the container is X liters. Amount of milk present in the container is 40 liters. So every time we are going to remove 4 liters of milk. So we take this as X. So amount of milk replaced with water every time is going to be 4 liters. We take this as Y. and this is going to be repeated how many times? N is going to be, once we did it, and we are going to do 2 more times, so it is 1 plus 2, that is equal to 3. And for this problem we are having a direct formula for this to solve. Amount of milk present after such replacement is equal to x into 1 minus y by x whole power n. We have the values for this expression. X value is going to be 40, 1 minus y value is going to be 4, and again x value is going to be 10, and n value is going to be 3. We take LCM, it is going to be 10 minus 4 by 10 whole cube, so 40 into 6 cube divided by 10 cube. We have to simplify this expression. 40 into 6 cube is going to be 216 divided by 10 cube, 1000. So we cancel this one. So we have 216 multiplied with the 4. So 864 divided by 100, which is nothing but 8.64 liters of milk will be present after such replacement. So this is the final answer. So we have the formula x into 1 minus y by x whole power n. We substitute all the data here. So your x value is 40 into 1 minus y value is going to be 4 liters, and here x value is going to be again 40, and n value is going to be 3. So 40 into, we cancel this one, this is 1 by 10. So 1 minus 1 by 10 whole power 3. We take LCM now. 40 into, when you take LCM, it will be 10 minus 1 by 10 whole power 3. That is 40 into 9 by 10 whole power 3, which is equal to 40 into 9 cube, 729 divided by 1000. We cancel 10. So now it is 729 multiplied with the 4. 4 9s are 36, balance 3, 4 2s are 8, 8 plus 3, 11, balance 1, 4 7s are 28, so 29. So 2916 divided by 100. And the final answer is 29.16 liters. So this is our final answer. So if the container going to contain 40 liters of milk, and every time if you are going to replace 4 liters of milk with 4 liters of water, if you perform this 2 more times, then amount of milk present in the container will be 29.16 liters. Hi students, today we are going to see another problem. From a container containing 50 liters of milk, 8 liters of milk was taken out and replaced by water. This process repeated 2 more times. How much milk is now left in the container? So we are having 50 liters of milk, and every time we are going to replace 8 liters of milk with water, and we are going to perform this one for 2 more times. Then we are going to find out the quantity of milk present in the container. Okay. So we start. Amount of milk present in the container. which is taken as X, and it will be 50 liters. And we are going to replace certain amount of milk. So amount of milk replaced with water each time. Every time we are going to replace 8 liters of milk with water, and we take it as 5. And this is repeated three times. And amount of milk present after such replacement. Amount of milk present in the container after such 3 replacements. We are going to use the formula x into 1 minus y by x whole power n. So we substitute the values. 50 into 1 minus 8 by 50 whole power n. 50 into 1 minus, we divide this one, 8 by 50. So we will get 4 divided by 25 whole power 3. We replace n value by 3. So we take LCM. 50 into 25 minus 4 divided by 25 whole power 3. So it is 50 into 21 by 25 whole power 3. We are going to simplify this expression. 21 divided by 25. We can't divide 21 by 25, so you will put 0.210. In 210, your 25 will go 8 times. So 8 into 25, 200, balance 10. We add 0 over it. So 4 times 25. So this is 0. So this is equal to 50 into 0.4 whole cube. So 50 into, we again find the value for 0.84 whole cube. .84 into 0.84. 4 4s are 16, balance 1. 4 8s are 32, 33. 8 4s are 32, balance 3. 8 8s are 64, 6 7. 6 5 0 7. So it is 0.7056. Again I multiplied with 0.84. We multiply. 4 6 are 24, balance 2. 4 5s are 20, 20 plus 2 22. 4 7s are 28. Multiplied with 8. 8 6 are 48, balance 4. 8 5s are 40, 44. 8 7s are 56. We add now. 4 0 7 2, balance 1, 8 9. 0.59274. So it is 0.592704. And we multiply 50 with the 0.592704, and it is happens to be 29.6352. So this is the final answer. A container has 50 liters of juice. 5 liters of juice is taken out and is replaced with 5 liters of water. Now juice is replaced with water. This process is repeated 4 more times. So we are going to perform this process of replacing the juice with water 5 times totally. So first time we are replacing the juice with water, and again it is repeated 4 more times. So n is going to be 5. So we start the problem. So quantity of juice present in the container. Initially it is going to be taken as X. We take it as 50 liters. Now quantity of juice replaced with water each time. So each time we are going to replace the juice with water, and it is going to be 5 liters. And we perform this one number of times it is repeated. N is taken as 4 plus 1, 5 times. So we are going to find quantity of juice present after 5 such replacement is equal to, we are having the formula x into 1 minus y by x whole power n. We substitute now. X is going to be 50, 1 minus y value is going to be 5, and x value is again going to be 50, and n is going to be 5. And 50 into 1 minus, we cancel this one. So it is 10. 1 by 10 whole power 5. We take LCM now. 50 into 10 minus 1 by 10 whole power 5. So you simplify this expression, it is going to be 50 into 9 by 10 whole power 5. And 50 into 0.9 whole power 5. And they are given the value for 0.9 whole power 5. 0.9 whole power 5 is given to be 0.59049. Now we have to multiply 50 with this. When you multiply 0.59049 with 50. 0, 5 9s are 45, balance 4, 5 4s are 40, 40 plus 4, 44, 5 9s are 45, balance 4, 5 5s are 25, 25 plus 4, 29. So it is going to be 29.54450 liters. This is the final answer. We multiply 0.59049 with 50. So it is 0. 5 9s are 45, balance 4. So we multiply 0.59049 with the 50. So 0. 5 9s are 45, balance 4. 5 4s are 20, 20 plus 4, 24, because 0 over there we write 24 as such. 5 9s are 45, balance 4, 5 5s are 25, 25 plus 4, 29. So the final answer is 29.52450 liters. So this is the answer. Now we are having a different problem now. From a container full of alcohol, 6 liters of alcohol was drawn out and replaced by water. Certain amount of alcohol is there, and we are going to replace every time 6 liters of alcohol with water. In this process of replacing alcohol with water, repeated one more time, then the ratio of the quantity of alcohol and water left in the container is 9:16. We are supposed to find how many liters of alcohol did the container hold originally. So initially how much of liquor or alcohol we add, that we are supposed to find out. So we start the problem. Quantity of alcohol. Quantity of alcohol. Present initially. B X liters. We are going to find the value for X now. Amount or quantity of alcohol replaced each time. Replaced each time. B Y. And it is given to us 6 liters of alcohols are replaced, so it is going to be 6 liters, and this process is repeated two times. N is going to be 2 times. Now we are going to find amount of alcohol present in the container after 2 such replacement. It is going to be X into 1 minus y by x whole power n, and we substitute the value x into 1 minus 6 by x whole power n, and n values we are going to replace. N value is going to be 2. So this is the amount of alcohol present in the container after 2 such replacement, x into 1 minus 6 by x whole square. Now they are given the ratio, the quantity of alcohol and water left in the container is 9:16. So after replacement, ratio of alcohol and water is 9:16. So we find the total ratio amount 9 plus 16, which is equal to 25. Now instead of finding the ratio with water, we are going to find the ratio with the original amount of alcohol. So I am going to find the ratio. The amount of alcohol present after such replacement, 1 minus 6 by x whole square to the initial amount x is going to be 9 divided by 25. So we cancel x, and this 9 can be written as 3 by 5 whole square, because left hand side we are going to have the square term 1 minus 6 by x whole square is equal to 3 by 5 the whole square. We try to simplify this expression. We take square root on both sides. So 1 minus 6 by x is equal to 3 by 5, because the square root cannot be negative. So 1 minus 3 by 5 is equal to 6 by x, which implies 6 by x is equal to, we take LCM and simplify, 5 minus 3 by 5, which is equal to 2 by 5. So ultimately the initial amount of alcohol present, X is equal to 5 into 6 divided by 2 by cross multiplication rule. So this is equal to 30 by 2, 15 liters. So initial amount of alcohol present in the container is going to be 15 liters.